Bismillahirrahmanirrahim. So let us start our module 4. In this module, we will be studying the defining the material properties as per the code, and then we will be defining the section properties for the columns, beams, and structure walls as per the ACI 1314. The first one is the concrete compressive strength FC prime, and according to ACI 1314, FC prime should be specified as per table 9.2.1.1, and this is the general table in which there is an application tab. There is a concrete minimum FC prime and maximum FC prime. So if you are using the normal weight concrete and the lightweight concrete, the minimum value of the FC prime should be 2500 FC prime, 2500, and there is no limitation on the maximum FC prime, right? But if you are using the concrete for the special moment frames and general structure and special structure walls, so the minimum FC prime value for the normal weight and the lightweight is 3000 psi, and there is no limit on the normal weight concrete for the special moment, but there is a limit on the lightweight concrete for the special moment frame, which is the 5000 psi. So for the SMRF, the minimum value for the FC prime should be 3000 psi, right? So the next one is the concrete modulus of elasticity. According to the CI 1314, modulus of elasticity shall be calculated as per the given equations. And for the normal weight concrete, this equation is normally used because if you insert the value of the WC between 90 to 160 in this equation, so this equation will give you the normal weight concrete equation, which is the 57,000 under root the FC prime. I'm discussing this because if you are designing your structure for example 5,500 psi, so there is no built-in material property in the ETABS, so you have to define it manually. So that is how you can calculate the elasticity for the that concrete. So let us go to the ETAB and let us define material properties, and there is a tab in which there is add new material property. Click on this. So there is a new tab and we have to select the region, whether it is United States, Spain, Vietnam, Europe, China, and the material type. This is the structural steel, this is the concrete, this is aluminum, cold forms, and these are the rebars. We will be using rebars, and this is the tendon and this is the masonry, right? So you will select the concrete for this time, and you have to select the grade. What is the FC prime? These four are for the normal weight and the remaining is for the lightweight. So we will select FC prime 3000 psi and click OK. So it will define the 3000 psi concrete. Again, if you want to define the another FC prime, for example 5000 for the columns and for the structure walls, we click OK. So 5000 psi concrete will be defined. So if you want to define concrete, for example 4500, so you have to take copy from this. For example, let me take copy from 5000 psi. Take copy from this material and then insert, for example 500 psi, and click on the design property data, which is the modifier show material property design, and click in here 4500 pound per inch square. Now the value you have to insert also the e value for the specified fc prime. So that will be, for example, square root of 400 500 4500, and this will be multiplied with the copy this. This is a number. We will copy this values and we will insert it here. So now this material property is now okay. If you don't define the e value for the specific fc prime, the calculations, the software will calculate the different stresses and strain and the demand to capacity ratios based on this e value, which will be very wrong. Right? Click on OK. Okay. So this is how you can define your own fc prime. The next is the steel bars. And according to ACI 318-14, steel bars to be used shall be from the given list, and these should be defound bars. The ASTM A615, ASTM A706, and ASTM A996, and the remaining is the stainless steel and low carbon. The normal concrete that we are, the normal steel or defound bars that we are using in our construction is the ASTM A615. Nowadays, the ASTM A706 is also available in the market, but is very expensive. So there is also a limitations on the defound bars given in the ACI code in table 20.2.4a for the non-pre-stressed deformed reinforcement, that if this is for the usage. For example, if you are designing your structure or you are using the bars for the flexure axial forces, and the application is the, for example, special seismic system, so the maximum value of fy permitted for the design calculation is 60,000, for example, means grade 60 steel that have to be used. And the defound bars is permitted. Defound wires reinforcement, welded defound bars mates, these are not permitted. You cannot use these. And for the similarly for the lateral supports, for the shears, for the torsion, there are the different applications given, and there is a limitation on the maximum value of the fy to be used for that specific design. For example, for the shear in the special moment seismic system, it is restricted to use the fy maximum up to 6000 psi, and the deform bar should be A615, A706, A955, etc. And similarly for the torsion, the longitudinal transverse reinforcement to be used, the maximum value should be taken as fy is equal to 60,000 psi. There's also some checks on the strength of the defound bars. For the ASTM 706 and grade 60, for the ASTM 615 grade 40 reinforcement 1 and 2 are to be satisfied, and for the ASTM 615 grade 60 reinforcement 1 and 3 shall be satisfied. The first one is the actual yield strength based on the mild test does not exceed Fy by more than 18,000 psi. It means that the design specified value of Fy, for example, is 60. So the value from the test should not be greater than 78 psi, 78,000 psi. So this value should be keep in mind while you are working in your field, or if someone send you test results for the rebars, that the value of the specified value of the Fy should not be greater than by 18,000 psi. That should be the difference between the actual and the specified. Then the ratio of the actual tensile strength to the actual yield strength is at least 1.25. It means that the actual tensile strength and the actual yield strength, these two values will be given from will be taken from the test results, and these values should the value of the ratio should be at least 1.25. If its value is greater than less than 1.25, then it is brittle material, then you have to reject that bars. Similarly, if the value is the difference between the uh, actual yield strength and the specified Fy is greater than 18,000 psi, then you have to reject that steel. And similarly, for the third one is for only for the grade 60 steel. These two are applicable for both, and this is only applicable for grade 60. That the minimum elongation in the in 8-inch shall be at least 14% for bar size number 3 to number 6. From for the number 3 to number 6 bar, the elongation should be minimum of 14%, and at least 12% for the bar greater than 7 to 11, and the 10% for the bar size for the 11 to 18. And if this value is also not certified from the actual test, again you have to reject the reinforcement. So before going towards the columns, let us define the rebars. Go to define material properties, click on the add new material, select the United States because we are following ACI code. Select this time rebar, not the steel, and there is a list of the rebars A615, A706. Only two are available this time. We will select A615, and that is grade 60, 40, or 70. We will select grade 60, click OK, and you can see there is a complete properties and design properties. Let me click on this. You can see there is a tab open in which there is a minimum yield strength, which is the software will use. This is the ultimate strength, this is the expected yield strength, and this is the expected tensile strength. These two values actually are used in the non-linear analysis, not in the linear analysis. These two values are used in the linear analysis, and these two are used in the non-linear analysis, for example, time history analysis or the pushover analysis. Click OK. Now the rebars has been defined. Now there is no such limitation on the columns for the general purpose as long as you provide the minimum reinforcement as you select any size of the columns for your desired building. You can visit ACI 31814 chapter 10 section R 10.3, and this chapter 10 is to be used when you are designing your structure only for the gravity loads or for the general purpose. And the limitation on this is 1% to 8%, right? So this is the code section in which there is explicit minimum size for the column owner specified to permit use of the reinforced concrete columns. The columns for the SMF, which is special moment frame, the columns for the special moment frames are have special requirements. Chapter 18, section 18.7 as compared to column requirements mentioned in the chapter 10. There is also dimensional limitation, which I have explained earlier in our previous modules, that using SMRF R value is 8, then you are done, you have designed your structure as SMRF. Not satisfying all the requirements of the SMRF, that will be the actual design of the special moment frame, right? If you have given the value of R is equal to 8 in the ETAB, and you have not fulfilled all the requirements of the SMRF as per the code, then your design is totally wrong, right? So these checks should be satisfied if you are designing your columns or your frame or your building as a SMRF. So the dimension limits says that the column should satisfy A and B. It means that the shortest cross-sectional dimension mentioned on the straight line passing through a geometrical standpoint should be at least 12 inches. It means that if you are designing your structure in zone, for example, zone 1, 2, 3, 4, every zone, that the minimum thickness for the column should be at least 12 inches. It means the 12 cross 12 inches square column is the minimum thickness to be used in the SMRF. And the ratio of the shortest cross-section dimension to the perpendicular dimension shall be at least zero point 0.4. It means, for example, if you have a column 36 cross 24, it means that the ratio to the shortest, for example 24 divided by 36, this ratio should be greater than or equal to zero point 0.4. This time the value is 0.6, so you can use that column as a SMRF in the SMRF framing. For example, if you have a column 12, this is one dimension, another is 36 dimension, and if you divide this 12 by 36, so this ratio is less than zero point 0.4. It means this column cannot be used in the uh, frame in the SMRF. Then you have to increase the thickness of the width. For example, take it as a 18, so the ratio will be 0.4, or decrease this one, for example make it 30. So at this we have to make sure that the ratio is greater than or equal to 0.4. Now the question is, for example, there is a requirement, and if you want to use 12 cross 36, and you cannot increase the thickness from 12 and you cannot decrease the thickness from 36, so what is the solution? Then you have to deal this element as a shear wall, not as a column, right? So if the ratio is less than 0.4, then you have to deal it as a shear wall, and if the ratio is greater than or equal to 0.4, so deal it as a column, right? The longitudinal reinforcement limitation for the columns in the SMF is from 1% to 6%, whereas in the columns for the general use or only for the gravity, the limitation is from 1% to 8%. You can study that in the chapter number 10 and these in the chapter number 18. Let me turn on the charger. So let us define our column section. We'll go to the define section properties, and let us go to the frame sections. There are the different tabs available. Click on the new add new property. You can select these are for the concrete, this is for the steel, this is for the steel composite, and this is for the special. There's a section designer in which you can design your own section. This is non-prismatic, this is auto list, and this is the general section. We will select the concrete rectangular section, and we will name it as, for example, C24 plus 24, and we will define as 5000 psi. We will select the material from here, FC prime concrete 5000 psi. This is the nominal size data. This is the actual time dependent parameters for the non-linear analysis, and this is the display color notes. If you want to add something, you can write in here. And the next one is the section dimensions, and we will add 24 into 24. And the next is the reinforcement. Click on the modify, and you can select the rebar, whether it is grade 60 or grade 40. You have to select for the longitudinal bars and for the ties. And this is the design type, whether it is a column or whether it is a beam. The reinforcement configuration is rectangular, and the confinement bars are the ties. And the check, it means that we want to design, we want ETABS to design this column for us. And these are values for the existing columns. If you are checking the existing columns, So you have to insert the value of the reinforcement, and then you have to click on the check. So this time we are designing, so you click on design and you will click on OK, right? The next thing is, let me go, it is actually at the end. The stiffness modifiers you can add with different methods, but if you define it with the defining the section material section properties, then it would be good. In the numerical model, the stiffness reduction factors shall be applied as per the code in the table 6.6.3.11 to incorporate the effect of cracking of concrete during linear elastic analysis. These values has been taken from different researches, then they have adopted in the code. It means that when there is crack occurs in the column, it means that it loses its 30% of the capacity. So that's why they have given the value of zero point 0.7. It means that in actual model there will be elastic deformation that will be beyond the elastic limits. So when the crack occurs in the column, so it immediately its 30% capacity will be reduced. That's why the code says for the new design you have to use zero point 0.7 into IG, moment of inertia. And this is for the columns. And for the walls, if you designing it as uncracked, take it as zero point 0.7, or if you are designing it as a cracked section, then you have to take it 0.35 IG. Similarly, for the beams, the value of modifier is 0.35, and for the flat plate and flat slab, it is 0.25 IG. For the column, you will define it as a 0.7 IG. Again, we will go to the defined section properties frame section, and the column we have defined, we will modify, and we will click this time the property modifiers, and you can see there is a cross sectional area, a shear area in the direction 2, direction 3, torsion constant, and this is the moment of inertia in the 2 axis and in the 3 axis. We will insert 0.7 in the both axes. The next is the beams. Initially, minimum depth of the beam shall be calculated